Hello, welcome to Fun with Flags. Oops, wrong channel. Let's start again. Welcome to the MISER Hydraulic Hybrid channel. This is a screencast of our first version of the LabVIEW dashboard to show the physical simulation of the vehicle done in MATLAB. This particular vehicle is a 25-ton long-haul truck running against a drive cycle designed for a normal passenger sedan. Let's begin. This is the dashboard. It is a simplified console that removes clutches and control charts to give an end-user perspective. That is, what a driver would see. Here is the system pressure in bar. Here we have the pump and engine RPM. Here is the pump's displacement. Notice that it goes from -5 to +5. This is the MISER over-center open loop pump in the patent. Every other display is also captioned. This slider bar is what the driver would do with the foot pedals. For ease of display, we have the brake and the accelerator in one. Positive means we are demanding positive torque. Negative means negative torque. You'll see that during the simulation that sometimes the pump displacement, that's this one, will change without the accelerator changing. That is the controller balancing demand, changing modes, and managing fuel consumption. The point of this developer's console is to see that the pump and engine change while maintaining demanded speed as we proceed through the drive cycle. These dials and sliders will be easier to understand once the model is running. So now we will show you the physical simulation model in Simulink, MATLAB, before running it on the background and viewing the display. Let's keep it simple. This is the physical model in Simulink MATLAB. Let me show you a few interesting blocks. This is Simulink's model of a vehicle body. You can enter most parameters here in the text boxes and it will do the maths of how the world physics acts upon a vehicle. Similarly, this is the variable displacement hydraulic machine which we use. You can enter all relevant parameters. Here we have used MATLAB variables to ensure switching between pumps is accurate and fast. This is a particularly interesting block. It is the basis for our entire control system. We don't have time for the details of state flow, but this is the chart that controls the changes between modes, such as regenerative braking, torque summing, and pump only. During those states, it controls engine throttle, pump displacement, and clutches. We will have this running as a display later. Now, with the vehicle and drive cycle running in the background, a good way into the drive cycle, this is the display console. You can see it reacting to the demand, switching between pump only, torque summing, and engine only where needed. Engine only is not displayed in this run. Here we see the engine RPM. This is the pump displacement. This is the system pressure changing based on power being added or subtracted from the system. All of this is happening because the state flow chart is running in MATLAB. Here is the display from the model. This is the velocity demand versus achieved scope. The demand is coming from a pre-programmed drive cycle for a passenger car. The closer the yellow line is to the blue line, the better the control system is performing. This display is in meters per second and not kilometers per hour, as on the display in the console. Notice that we are not running in real time and can go above or below actual real time. This is a 25-ton truck without any engine modifications and only MISER being added to the powertrain, performing similarly to a sedan. Here is the engine output scope, showing instantaneous RPM, output torque, and power. Here is the pump output scope, showing its performance during the drive cycle. Notice that it adds and subtracts power and torque from the system. Here is the state flow chart showing the control system triggering different modes, as speed, pressure, and demand changes. This has been an introduction for the work being done on part MISER's control system. There will be a similar video to show the work on full MISER's control system later. The work still to be done is to improve the performance of the control system, further optimization for emissions reduction, fuel saving, and to implement further performance boost. Thank you for watching.